Good afternoon, everybody. Welcome to our regular meeting for September 24th, 2018. I do note that we do have a quorum today with 4 members present. Thank you very much for joining us. And today we just have 5 items for information. So the first item is our Red Hill Bulk Fuel Facility update. Chair recognizes Mr. Erwin Kawata.
Thank you, Chair. Good afternoon, Chair and members. For this month, I would just want to share with you some updates with respect to the work we're doing on the Red Hill Bulk Storage Fuel Facility. Specifically, share with you some photos and examination of some samples that were collected from the actual steel liner from tank number 14, and kind of go into the latest discussions that the Navy's having regarding the tank upgrade alternative selection. So part of the process with respect under the administrative order consent is to understand, what is the actual condition of the individual tanks. And so specifically, this particular effort has to do with taking a look at what is the condition of the liner itself on the side of where the fuel is located, and on the opposite side, called the back side. Currently, there is a technique called non-destructive evaluation where these samples or the actual tank itself is being scanned to understand what is the remaining thickness of the actual liner, so that the Navy knows where to go and do any kinds of repairs. Now, just as a start, each of the liners, or the entire liner itself, is a 1/4 inch thick, is the original thickness. So that's 0.25 inches. So part of this exercise is to take samples of this particular liner and compare that to what the non-destructive or NDE test results predict as to the remaining thickness, and actually see what's really there. The other thing too is to understand what's happening on the backside. The backside of the actual liner, you have the cement grout supported by the existing rock. And that initially when the rock or the grout or the cement was poured, it's in direct contact with the liner, and that serves as a way of passivating or preventing any kind of weathering or corrosion to the steel liner itself. As you know, steel in contact with moisture, it can lead to rust. But as time goes on, these tanks were built in the 1940s, and so as the tanks fill, empty, there's a certain amount of change in the movement of the liner and some weathering that's occurring. So there's thoughts that there could be some space in between where water can actually get in between the liner and the cement itself. Initial reports that was done by the Navy indicated that backside corrosion was not a concern. So there were 10 samples taken, each one 12 by 12 inches. Each particular sample cut from the tank is called a coupon. The coupons were displayed on June 25th and gave opportunity for stakeholders and the regulatory agencies to kind of view what it looks like on the fuel side up. This is all 10 samples with the fuel side facing upwards, and then reversed, all the backside facing upwards. So we'll take a closer look at some of the individual samples. Now, all the samples were collected from 4 very specific places: the lower dome, the barrel itself, the upper dome, and this expansion ring section. We don't know where along these areas the 10 samples were collected, because if you look at the 10 samples in relation to the whole, it's a very small percentage. We don't know where, but we know from what areas the tanks were sampled. The liner itself was sampled. So let's take a first one. This is the expansion ring. This is the fuel side. So the expansion ring is located up in this region at close to the 200-foot level. This is where the site of the fuel is. For the most part, it has this existing green tint, and beyond that, not so much that you see. But on the back side, we see a very different kind of a picture. We see what appears to us some corrosion. This silver area is what we believe is to be the grout. We see some very black looking, what appears to be potentially hydrocarbon in nature. You can see here this marking. It looks like watermarks dripping down along the side. The remaining thickness was predicted to be about 0.15 to 0.17 inches. What was actually measured is less than that, 0.118 inches remaining thickness. Moving on to the barrel, same thing. We see this is the side that's exposed to the fuel. Again, the green tint, probably a past type of painting or coating that was applied. This is the backside of this particular barrel. We see a large amount of corrosion or rust occurring. The thickness that was predicted by the NDE, anywhere between 0.135 to 0.187. Actual remaining thickness, very much less than that, just under 0.08 inches. So very, very thin. This is the lower dome. The lower dome is very interesting. Again, we see the green type of kind of coating that was applied in the lower dome. On the back side, very different picture. We see this very dark, what appeared to us to look like some kind of hydrocarbon staining. As you remember, all of the tanks hold jet fuel, petroleum products, so you see this dark hydrocarbon staining. The remaining thickness, 0.2 inches, what was predicted, we actually see 0.25, so no corrosion on the back side. Now, as you know, corrosion happens when steel comes into contact with moisture. So obviously there's no moisture there, but if there's petroleum there, it prevents the moisture from coming into direct contact with the steel. So they're suspecting here that this is some kind of a hydrocarbon staining, but we need to wait for the Navy's full completed report and the analysis to come back to better understand what we're seeing here. So in review, there's definitely a presence of backside corrosion. Out of the 10 samples that we saw, there were at least, all of them had some amount of corrosion on them. Some had obviously much more than others, but for the most part, about 5 out of the 10 had a lot of corrosion that we saw. We also observed staining on the backside of these steel plates, what appeared to look like hydrocarbon staining for a good number of the coupons that were sampled. Finally, the concern here is that based on what the NDE was predicting in terms of what is the remaining thickness and what was actually observed, it's much less than what the NDE is able to predict. And so the concern here is that is the technique unable to find areas of thinned or remaining wall thickness that need to be repaired, but the measurement is unable to do so. So it's underestimating the need to do some repairs. So moving on, in terms of the tank upgrade, the Navy, as you know, has put out 6 different options in terms of tank upgrade. 3 of them are a single wall, 2 of them is a composite type, and finally the number 3A is the tank within the tank, or commonly known as secondary containment. The Navy has also proposed some additional tanks further up the hill as part of an alternative site study that the Navy conducted. This one is what they've indicated as pretty much their choice. It's basically have the existing 20 tanks here, and then further up the ridge, another 40 additional tanks. This was released in the early part of this year in March. The advertiser put out a nice graphic that laid out all the different cost ranges for all the different options. The single wall here, the composite, the tank within the tank, secondary containment, and of course this is the alternative location further up the ridge of the 40 tanks. So the cost ranging anywhere from $450 million all the way up to $10 billion. So in terms of the individual tanks types, first of all is a single wall. You have the existing 1940s single quarter-inch steel. You have the existing liner here. It's supported by grout against the existing rock that the tanks were constructed. You have basically one single pathway. You have any kind of penetration that, let's say, corrosion that creates a hole that can allow fuel to move directly into the environment. So you have a direct communication or direct pathway to the environment of any kind of breach of this particular liner. The backside is not something that you're able to easily inspect. You can see the inside, but you cannot inspect the outside, and that's why there's reliance on such things as non-destructive evaluation techniques to try to understand what is the condition or the remaining thickness of the liner. The second one is the composite wall. It's installed another brand new liner here, 3-inch from the existing filled with a grout. Again, it's not a 1/4 inch steel, it's now a 3-inch thick single wall tank that in the event that there's any kind of breach between the inner and outer, it allows for a direct pathway to the environment. Finally, the interstitial or the secondary containment, there's an actual 5-foot space between the inner and then the outer wall. So any fuel that happens to leak past this inner wall gets collected, and there's no direct communication with the environment. Finally, this is the design for the 40 new tanks that the Navy is considering, is looking at. It's called the commonly cut and cover, where you dig a large hole, you construct the tanks, and then you bury the tank after you're done with construction. Again, we see a single liner supported by a layer, by grout, and then again the existing earth in which the tank was constructed. Again, you have another, for the most part, single wall type of design, although it's thought that this cement here actually, is actually that second layer, so there's some thought that it could be considered a double wall, 2-wall type of construction. But for the most part, it is one solid piece that any kind of, if it happens to breach, it can move directly from within the tank up to outside into the into the environment. So recently in August, the Navy indicated or sent out a stakeholder letter in August of this year, and it indicated in there that the proposed tank upgrade way forward for the Navy is to continue the existing tank maintenance in accordance with its current procedures as their best decision so far. So it's the existing way that they maintain the existing single wall tanks is what the Navy is proposing as their choice at this point. They've listed a number of reasons for that particular choice at this point. For us, a number of them, we have expressed our concerns with respect to how these different reasons are not really measuring up in terms of supporting that particular choice. So for us, again, we favor the secondary containment just strictly because there is a place for any fuel that's leaked to get collected, and it prevents it communicating a pathway directly into the environment as opposed to the existing single wall design. The choice that the Navy is currently kind of favoring, although the decision has not yet been made, that they're favoring is this called 1A, which is the existing clean, inspect, maintain procedure that they're applying every 3 years, and to just simply coat the bottom of the tank. So the next steps, the Navy is in the process of preparing a final report submitted to the regulatory agencies. They have until right now the current timeline by the end of the year. There is thoughts or discussions about having an opportunity for the community to provide input into this particular process. Once the decision will be made, the regulatory agency will give the Navy the approval to proceed. And while the tank upgrade decision can be revisited every 5 years according to the administrative order consent, from a practical reason, once you start implementing some kind of corrective or improvement, it's hard to change it every 5 years. So we have had some questions about what is the process for doing that, and then we're still waiting on a final report from the Navy where we can better understand that. And that concludes my report for the month. For the board members, I do want to introduce members of our technical team who are here on island today. Larry Eisenstein with Exponent, Joe Tracy with Terra, and David Brown with Morgan Lewis.
Are there any questions from the board?
Members, any questions? Any comments?
Thank you, Aaron, for your report. The final decision on which upgrade option to be implemented will be with the Department of Health, the state of Hawaii, and also with the US EPA.
So So as far as BWS's comments, how will those be submitted?
I'll probably do it in writing, and if there is a public, opportunity for public testimony be provided, we may be there to provide that testimony.
I see. Will there be, is there, once we submit comments, is there going to be a response or a decision just?
Typically, what we've seen in the past is we've made our comments, they receive comments from the community, then they issue a decision thereafter. May or may not incorporate recommendations from our comments. We have no control over that.
Okay, thank
Okay.
you.
Thank you.
Thank you.
Thanks, Alan.
All right, next up on the agenda is item number 2 for information. This is the overview of the Board of Water Supply Emergency Preparedness Actions for Tropical Cyclones. Chair recognizes Mr. Robert Morita.
Good afternoon, Chair Andaya, board members. So it was fortuitous, I think. It was always, it was scheduled for a while to have this briefing on the Board of Water Supply's emergency preparedness plans. And then we had Hurricane Lane come upon us, as well as Olivia as well. So what we decided to do was to still continue with the briefing for emergency preparedness planning at Board of Water Supply, but we'll also give you updates on most recently Olivia and the events that occurred at Nu'uanu Reservoir number 1. And I apologize for the length of the presentation, so I'll try and get through it as quickly as I can. It is in your board notes, and the presentation will also be part of the publicly available minutes. So at Board of Water Supply, we are standardizing on the incident command system, and effectively it's to ensure that the protection, safety, and readiness of our personnel before, during, and after these events happen is consistent. Our main goal is to provide water service to the largest number of customers possible, and also to support our critical infrastructures and facilities relating to water service. This image came up during Hurricane Olivia. So on or about September 9th, September 10th, thereabouts, this was a snapshot in time of all of the major weather events that were happening around the globe. And typically during hurricane season, it's an either-or thing between the Pacific Ocean and the Atlantic Ocean, where typically one ocean is more active than the other. This year is a very different story, where we're getting major weather events in both oceans. And basically countries and coastlines around the world are being affected. And so in this situation, there were 9 major events, anything from a major tropical depression to I think, I hope I'm saying it correct, Mangkhut, and that really devastated the Philippines as well as China. I believe that was a category 4 when it hit the Philippines. So we're seeing some major systems affect the entire globe, basically, this hurricane season. And as a reminder too, only as recently as 2015, the Central Pacific had never seen 2 simultaneous category 4 hurricanes at any one given time. But yet in 2015, in the Central Pacific, there were actually 3 concurrent category 4 systems. We were extremely fortunate in that none of these had any major impacts on Hawaii. But again, this is just a constant reminder to us as far as how much we need to be prepared for major events. Recently, we did have Hurricane Lane and Olivia out there. Hurricane Lane was one of the biggest activations that I think the city has seen in recent memory. And the problem with Lane was that while it was predicted by the National Weather Service that it would make this 90-degree left turn before it reached the Hawaiian Islands. The problem was that it needed to land on our doorstep before that particular turn took place. So it was pretty stressful during that time. Olivia, on the other hand, was a tropical storm when it reached Hawaii, between Maui, Oahu, and the Big Island. But like all these major systems, it was really unknown how much of a wind event it would be, but we knew for sure that it was going to be a major rain event. And with rains, it can cause quite a bit of havoc with relation to flooding and property damage. So as part of our preparation, and as well, and this carries over to the public notification as well, we constantly try to communicate to the public about preparation, preparing yourselves and your families for these events. And so what we stress is that at a minimum, each family should have a minimum of 1 gallon of drinkable water per person per day for up to, now the new standard is for 14 days. It used to be 7 up until a couple of years ago. But the Hawaii Emergency Management Agency has upped that number to 14 days. And I think we've seen it with a situation like Puerto Rico. 14 days sometimes is seen as not being enough. But we know that there are certain constraints that limit that ability to hold that much provision. But still, we maintain that standard of 14 days. Prescription medicines, pets, and food and water. That became a big issue during Katrina, where pets were not being either rescued or being housed in shelters, and that became a major issue. It put a lot of people as well as first responders in jeopardy because of the pet situations. And cash and possibly traveler's checks as options to maintain a certain bank, I guess, of cash and traveler's checks. Because in an extended situation, credit only goes so far. If you lose power for an extended period, again, as we saw in Puerto Rico, cash became king. And that was, in a lot of situations, that was the only way to conduct business. This slide shows you during one of our major annual maintenance of our mobile generators. So here you see 6 out of our 7 generators out at our Manana yard being serviced. So we do have 7 portable mobile generators, 6 900, almost a megawatt, and 1 500 kilowatt generator. We currently have, with a FEMA grant that we are hopefully going to get approval for shortly, we haven't heard otherwise that it's going to be a problem, for the purchase of another 500 kilowatt generator. And we are also budgeted this fiscal year using Board of Water Supply funds, another 900 kilowatt generator. During Olivia, we also went ahead and rented 2 more generators to house at our facilities, 1 more 500 and a 2 megawatt generator. So this slide shows you the current placement of our mobile generators, including the rentals. So they're strategically placed to try and service the maximum number of water customers possible. And going forward, we are also looking at putting permanent fixed generators at key locations as well. And so on this layout, you'll see that there's some duplication, and so obviously those areas where fixed generators are put into place, those mobile generators will be redeployed to other strategic areas. This is an image of what we call a fire pumper. These are very portable units. While they don't help us draw water from our sources, they are very helpful in moving water either across the island or basically uphill to get to locations where water may not be available. Our plan for tropical cyclones, it's continually being refined. It got a good exercise during Hurricane Lane. But as part of our general standard operating procedures, we will fill all water reservoirs to the maximum levels in order to just maximize storage of drinkable water in case of an extended power outage. Because without power, we're no longer able to pump and refill our reservoirs. So prior to the event happening, we try to maximize these locations. We also have a practice of fueling up all of our generators as well as vehicles prior to the events. As mentioned, we pre-position our mobile generators. And when the city's Department of Emergency Management goes to full activation of the EOC, the Emergency Operations Center, here at Board of Water Supply, we stand up our own departmental operations center here at Beretania and a smaller location over at our Manana yard. If necessary, if we feel storm surge is going to be a threat, we do have one base yard that's in an inundation zone, and that's out in Waianae. So when we feel a storm surge is an issue, then those vehicles are either moved to higher ground or even moved to other yards like at Manana. When events happen, we confirm our staffing because we need to staff up areas. We do have representatives at the Emergency Operations Center over in the Fosse Municipal Building, our Department Operations Center, the Manana Operations Center, some of our base yards, as well as a call center. Initially, all of these sites start off with 12-hour shifts in order to ensure continuity at all of these locations. We also inform our employees that once the all clear, once the event has passed, assuming that something happens here, that all Board of Water Supply employees are categorized as department disaster response workers, and that hopefully everything is fine over at their homes with their families, and that they are expected to report in once the all clear is given. We are also opening, we do open a call center during emergencies to answer any questions and also to help relay situational awareness information back to the Emergency Operations Center. We actively check the water levels at our open reservoirs, namely Nu'uanu 1, 4, and Mauna Olu out in Makaha. And if water storage capacity, stormwater capacity is needed, then we begin active siphoning, specifically at Nu'uanu Reservoir number 1. And that's where all the excitement happened with Olivia. Was it a week ago? It seemed like a long time.
Yeah.
Okay, so let's get right into it. So Nu'uanu Reservoir number 1, if you're not familiar, it's toward the bottom of Pali Highway, just below Oahu Country Club. So it's on the Ewa side of Pali Highway, just adjacent to Oahu Country Club. Constructed, and we got this from an earlier consultant report in 1905, but we actually found out that it was actually built in 1889, so well over 100 years old. The whole purpose of it was to provide water and hydroelectric power for Honolulu, but it is now simply an open reservoir used for flood control, really. It's not used for drinking water purposes at all. And the hydroelectric plant was decommissioned in 1930. The state designated Nu'uanu 1 as a regulated dam in 2014. The state contracted Gannett Fleming in 2014 to prepare a study. And based on that study, Board of Water Supply contracted Oceanit to develop hydrology and hydraulic analysis studies, engineering studies for these sites. This year, in fiscal year 2019, dam improvements design is scheduled to begin for Nu'uanu 1. It's budgeted at $1 million. So this is what Nu'uanu Reservoir 1 really looks like. It basically has a dam face of 34 feet high, and it's about 588 feet long. Over on the left side is the spillway for the dam, 3 foot wide by about 70 feet long. has a storage capacity of about 22 million with a surface area of about 6 acres. Board of Water Supply does own this parcel, and it was transferred to Board of Water Supply by presidential proclamation back in 1920. This is the tax map key, basically showing the property boundaries of what Nu'uanu 1 represents and the approximate size of the reservoir. So today, the dam is structurally stable. I need to reinforce that there is no threat of the dam collapsing or having any type of breach currently. We maintain the water level at a depth of 2.5 feet or even less. At 2.5 feet, basically, there's just a puddle in the middle of the reservoir. None of the water, at 2.5 feet, none of the water touches the sides of the dam itself. The spillway height is at 17 feet, and the crest of the dam, the top of the dam, is at 20.5 feet. Here's a sketch of what a cross-section of the dam looks like. And our methods of monitoring Nu'uanu 1, being that it's an earthen dam, we have basically three ways of keeping on top of the current water levels. One is using a remote gauge that was set up by DLNR and the USGS. We use that because we can remotely access the water levels using this tool. So we have access to that. Ever since Darby back in 2016, we do have a security camera at a nearby facility, so what we've done ever since then is dedicate that camera to point toward Nu'uanu 1 so that we can visually see what the water level looks like. And then there's inspections along the toe of the dam to monitor any seepage, because there should always be some seepage coming out of the dam if the reservoir is full, but if you see too much of it, then that could indicate a problem. 2017, there was an inspection conducted by the State Dam Safety Program, and it made several recommendations, and you see the list there. The biggest one that was most obvious was overgrown vegetation. The site had some trees and a lot of brush along the dam face itself, so a lot of work needed to go into it to clear up some of the vegetation that had grown quite large there. And also a key piece is the update of our existing emergency action plan for the dam. So here's some of the vegetation clearing that happened. So the top image is what it looked like. It was a nice walk. It was very wooded. A lot of the neighbors used to come walking in that area, but it was bad to have that much vegetation growing along the dam face. So a little more than a year ago, we undertook a contract to clear out all of the brush, and so the lower picture is basically what it looks like today. All right, so now getting back to Tropical Storm Olivia. This is a highlight, I guess, of the different water levels before and during Olivia. So prior to Olivia, we had Hurricane Lane, which did bring a lot of moisture, a lot of rain to the area. So while prior to Lane, effectively Nu'uanu 1 was dry. We weren't getting any readings off the gauge. But after Lane hit, even though it wasn't a hurricane, even though the winds never came, we did get a lot of moisture, a lot of rain. So after Lane, it went from what we call 2.5 feet up to 12.6 feet in water level. So very quickly, it rose roughly 10 feet. We did begin to siphon the water level because it was at a height, a water level that we weren't comfortable with. So we began to actively siphon the reservoir. But then Olivia came along. And so after Olivia came and went, the water levels jumped up about another 4.5 feet. And we'll go through a timeline very shortly. But once Olivia had passed, the water level had hit about 15.1 feet, which was about a foot and a half really from the spillway, reaching the spillway. And because it's an earthen dam, we would prefer, even though a spillway is designed to have water go over the side, because it's an earthen dam, as much as possible, we don't want the water to do that. So we try to prevent that from happening. So 17 feet is the spillway, and 19.5 feet is the top of the dam. So here's a timeline. So as I mentioned, so at the top, so here's the red line, the crest of the dam. The blue is the spillway height. 1 foot below, if water ever got to 1 foot below the crest of the dam, according to our emergency action plan for the dam, that would require mandatory evacuation of the houses and businesses below the dam. And as you can see here, we started at about 11 feet prior to Olivia, and we were able to get the water going down. And so we did that through simply gravity siphons. 2.5-inch hoses, flexible hoses, using gravity to siphon out the water. The evening of September 12th, the rains from Olivia arrived. According to rain gauges, it was about 8 inches of rainfall in the Nu'uanu area. So soon after the rains came, then the water levels rose in a very short amount of time, basically overnight. Water levels jumped about 4.5 feet. It was early on the morning of September 13th that the call went out to Board of Water Supply field crews to, as quickly as possible, get what we refer to as a trash pump. It's a mechanical pump out to the site to begin to try and lower the water levels at Nu'uanu 1. The gravity siphons were still in place, but it just couldn't keep up with the amount of water that was entering into the reservoir. Maximum height was reached at about noon that day. Even though the rains had stopped, it was just the residual runoff from all of the rain. Water levels continued to rise. And so that put us at about 1.5 feet of the spillway. So it was at that time that the Honolulu Fire Department also jumped in and offered the use of their engines, 2 of their engines, to help pump more water out of the reservoir. The next day, so we continued to pump. The next day, fire department pulled back their assets, but we had replacement pumps ready to go in place of the fire department trucks and pumps. And as you can see on the line, once we got the rented pumps in place, then the amount of draining significantly improved. Additional gravity siphons were put into place. Those are nice because they don't require any kind of refueling. As long as there's a vacuum in the water, the siphons just continue to run and they don't have to be staffed. The mechanical pumps do. They burn a lot of fuel. They have to be monitored to ensure that they run. And so we continue to pump and to siphon until basically we hit bottom again. So the interesting part is that it took roughly 6 to 8 hours, I think, for water to rise 4.5 feet. It took us nearly 6 days to empty out the reservoir using all of the resources that we had available to us. And as a matter of information, so on Thursday is when all of the news started to get out. So here's a mini timeline of the public notifications that went on. So at 7:30, we began the process of notifying city administration of what was happening at Nu'uanu 1. By 10 a.m., the first press release went out to the public in conjunction with the city, with the mayor's office. At 12:30, there was a press conference, which Mr. Lau was the attendee representing the Board of Water Supply. And at 3:30 that same afternoon was a second news release out to the public. And this is the scene at Nu'uanu 1, where when the fire department did show up and offered the use of their engines to help pump the water out of the reservoir. So a before and after. So before, this is early on Thursday morning with our 2 trash pumps going with some of the gravity siphons there. And this is seen, this is about, I think this is almost 6 days later. So basically this is a very shallow pond right here. I'd say at this point it's probably a foot high.
Foot deep.
Foot deep, okay. All right, and so this was the flood model developed for Nu'uanu 1. This was done by the Maui Pacific Disaster Center. So it shows, assuming a dam breach at capacity, which is, at capacity, it would be 35.1 million gallons of water stored. Assuming a full breach, it would flow downward Makai toward Honolulu Harbor. And the darker lines represent the deeper areas of the inundation flowing downhill. The evacuation plan has a map in there. It lays out, it basically shows which streets would be cordoned off, and the areas within this area, with the streets and the homes, businesses within this area would be evacuated should a full breach occur. So this is all part of the emergency action plan that we have for Nu'uanu 1. So as a matter of, well, just going forward, we do have several action items that we continually have to stay on top of, some that we have to undertake. But basically we are going to keep the water level low at Nu'uanu 1. There's no doubt about that. So should we run into another rain event, whether it's a hurricane or not, or whether it's just a major rain, if Nu'uanu 1 starts to fill up again, we will drain it, because we need that storage capacity. We also have a program to keep the vegetation down again, so that we don't encounter overgrowth again. We do have the design project going for improvements at the dam. And we will continue to refine the process and the procedures, working with the Mayor's Office, Department of Emergency Management, DLNR, probably even HAIMA to some degree on our emergency action plans. And a big one will be implementing an outreach program for the community and businesses about our regulated dams at Nu'uanu 1 and number 4. Oh, and Mauna Olu as well. Very quickly, I'll go through it. Nu'uanu Reservoir number 4, for your information. This is the one that's actually most familiar to the public, because this is where all the catfishing used to occur.
Catfish fishing? I'm sorry.
What did I say?
Catfishing.
Catfishing.
Catfish.
Catfish. Okay.
Big difference there. Okay.
Oh yeah, catfishing is something else. I get it. All right. It was constructed in 1910, reconstructed in 1934. Again, the purpose was for water supply and hydroelectric power, similar to Nu'uanu number 4. And again, the hydroelectric plant was decommissioned, and is similarly is used for flood control for the Nu'uanu Valley and Honolulu. There's an old photo of what the area used to look like. The very famous towers there. So similar to Nu'uanu 1, Nu'uanu 4 was designated as a regulated dam in 2008. Similar work was undertaken for Nu'uanu 4. But at Nu'uanu 4, we do have an active construction project underway for dam improvements there. Here at Nu'uanu 4, the dam embankment is 65 feet high. It's much larger, 1,750 feet long. And it has additional features on the dam itself to help control some of the water level there. Has a storage capacity of 1.173 million gallons at a total surface area of 110 acres. Here's an aerial shot of what the dam actually looks like. Again, it's Board of Water Supply, it's on Board of Water Supply land, it's under our control. Again, it was transferred by presidential proclamation in 1920. Tax map key. Here's information about the current construction job over at 104. The scope of work there, to dredge the reservoir, it has a lot of silt buildup. And from a security, because I oversee security, we still have issues with people trying to break in and to jump off the tower into the water. And it's very deceiving there because there's water depth markings on that tower, but the water depth is nowhere near those levels because of the silt. So we've had injuries, we've actually had a fatality years ago as a result of people jumping off of that tower. But regardless of our best attempts, it's difficult. It's been difficult to keep people out. They're just so determined to get in there. But there's various improvements going on currently, and as I mentioned, dredging the reservoir is part of it. So here's part of the timeline. The bridge itself is 95% repaired, and there's additional work to come in the future. There's improvements to the embankments as well. And here's a very recent photo of the construction work that's ongoing right now. Here's the timeline. So at New 104, the dam is structurally stable. Here's information about the spillway height, the crest of the dam. Again, it's because it's in a remote area, vegetation, keeping on top of the vegetation is a constant challenge. Here's a cross-section of the dam itself and the elevations. Flood model, similar to New 101. So you can see if there was to be a full dam breach and what would happen downslope of the dam. The evacuation plan that's outlined in the emergency action plan for New 104 covers a pretty broad area all the way down to Honolulu Harbor. We do have active monitoring of the water levels there through telemetry as well as visual observations. The dam safety inspection program, again, by the state, the state came in, made several recommendations, somewhat similar to what New 101 had, which is controlling the vegetation, clearing the spillway areas, updating the emergency action plan. Here at the dam, there was a lot of trees and vegetation that needed to be cleared out, which it was taken care of. There was additional actions taking place. I won't go through some of these. Similar to New 101, we work closely with our emergency management and state agencies to ensure that the dams work as they should. Okay, sorry for taking so long, but that's a highlight because it became front and center, I guess, as a result of Olivia, and we learned a lot from that, and we look forward to making improvements to the process so that, number one, the public is better notified, I think, of the reservoirs and the potential impacts of it. But then number two is to make sure that our plans are more robust and refined so that we can better take care of it before it becomes a crisis.
All right, thank you, Mr. Morita, for the report. Members, any questions? I got a few. So, Mr. Morita, on the permanent generators at our different base yards, what is the timeline for those?
Oh, if I could, on the timeline for the construction of the permanent
Yes.
generators. Jason, are you?
Yeah, we'll have Jason Takaki, head of our capital projects division, provide a timeline for completion and construction.
Okay.
We have a number of projects to install permanent generators at our facilities. We have one contract that's 3 different sites, Halawa Shaft, Kalihi Shaft, and Kunia. And a separate project is installing an emergency generator as part of the expansion of our Kahuku wells. So they all have different timelines. They're all in construction now, so within the year.
Okay.
Oh, and we have one more. We're building one right now in our courtyard, and you can actually see the construction from our picture glass window. They're putting up a canopy over the emergency generator. The generator's in place, as well as the tank, and they're making the final connections to the pump station, as well as the finishing up the exhaust.
Just a correction, the Kahuku is going into design. So after the design is complete, then that generator can be actually constructed. I think it's part of a standby well project.
It's in construction.
It's in construction right now? Okay.
And these generators are what will help our agency provide water to the public in case there is a natural disaster.
What happens, Chair, is that on our average day, our water demand's around 145 million gallons a day around the island. And that includes 94 different well sources and I think 90 or so pumps, booster pump stations. We depend on electricity. We have gravity sources, but most of our water demand's met by using electricity to pump water out of underground aquifers or to lift water up the ridges. So assuming we're hit with a hurricane that affects electric power coverage across the island of Oahu, depending on the rate that is restored, how quickly that's restored, will determine how much water we can provide to our community. So in the meantime, when we assume that maybe in the scenario with a Category 4 hurricane hitting Oahu, that the electric power, commercial electric power will be out for a while. So we'll have to turn on to backup power from these generators, either fixed or mobile. And right now, I think currently right now, this situation, we probably have enough generator capacity to pump about 50 million gallons or so of water from our aquifers. That is only a fraction of the 145 million gallon normal usage around the island. So there could be areas that don't have water supply initially. As electric power gets restored, we're going to restore pumping capability and provide water to all the community. So we're, like Robert said in his presentation, we target areas of high population around the island, also critical facilities such as hospitals, major medical centers. We want to make sure they have water as part of the recovery from a disaster. So I think that combination of generators plus these fire pumpers or these mobile pumping units, we can move water around our system, but it won't be normal water service after a hurricane hit. We'll try to get water out to everybody on the island the best we can. People may need to come to get water from certain points where there is water supply and to transport that back to their homes. It will be a challenge for a while.
Okay. All right. Thank you.
Thank you.
Moving to the new one reservoirs. So I understand that we actually do have emergency action plans for the reservoirs under our control.
Yes.
But we are going to be updating and refining them in cooperation with other city agencies.
Yeah.
Hopefully with Department of Emergency Management as a lead. And one of the things that we're going to focus on is the messaging and the outreach to the communities in the event of a potential natural disaster.
That's correct, Chair. So our messaging in New Orleans, number one, there is definitely room for improvement in our messaging. And I apologize to the community for creating confusion and for getting them. We're very worried about a situation that was not imminent. There was no imminent risk of failure of the dam. There's definitely room for better messaging and communication to our customers, to the communities downstream of these dams, and to more refinement of evacuation plans and how they will be implemented. So discussions also on how much time will it take to evacuate people out of these areas. We want to make sure that we back down, we have the trigger points of action at the water levels behind the reservoir to provide adequate time for evacuation. Right now, under our current EAP for new 101, that's 1 foot, the water level gets 1 foot lower than the top of the dam. So there's only 1 more foot to go before the dam overtops and potentially fails. So will that give enough time for the communities that could be impacted to be evacuated safely from those areas? That's a question we're going to be working on. It's going to be a very collaborative effort with the Department of Emergency Management, other city and agencies, and also discussion with state agencies. And actually, the meetings have also started. We have a meeting scheduled.
Please continue.
We have a meeting scheduled for tomorrow, so we know our actions at New 101 was really in response to, I think, the type of hurricane season we've seen this year, where it seems like every 2 to 3 weeks we're having a hurricane or tropical storm come our way. In fact, there's one developing off the east coast of the East Pacific right now, off Mexico. We'll have to watch that very closely. But it is definitely an opportunity to improve in the process and to be more transparent to our community, especially the populations that live downstream of those dams. I believe they have a right to know what is happening and to be alerted with enough time to take the appropriate actions to evacuate.
Okay, good. Yeah, I'm really happy that we do have an emergency action plan and that we will be updating and refining it, including the communication piece of it.
Definitely, Chair, that's a good lesson out of this experience.
Thank you. And then last question is, as far as the siphoning goes, to reduce or to bring down the water levels when it's necessary. I'm wondering what the effect is on the neighbors and where that water that's being siphoned is going and what remedial action we're taking.
You know, that's some of the challenges related to New Water Reservoir number 1. When you go immediately downstream of the dam, some of this water actually flows through properties. And remember, this dam could have been first constructed back in 1889 and maybe improved in 1905. We have to do more research here. But it's been a long time since the dam was there. And the dam, although it's not really meant originally for flood control, really was water supply and hydroelectricity. It's really kind of contained some of the storms and held back some of the storm water for slower release downstream. So that'll be a challenge for New 101, how to release the water safely. During the pumping and the use of the siphons, we monitored, well, along with the fire department and the other city and state agency, monitored downstream communities to see if there's any flooding that was happening. And we used that as a kind of a gauge of how much water we could send over the dam, down the area by Oahu Country Club, down to those properties, and how much we could also pump into a storm drain on Pali Highway. And I'm glad to say that by practical experience, we seem to know how much we can actually pump both ways before it becomes problematic for the downstream communities.
All right, thank you, Manager Lau. We look forward to working with you and continuing the education and communication with the communities that are possibly affected.
Thank you, Chair.
Members, any questions? Okay, hearing none, I'm going to move on to the next item for information. Item number 3 is the Board of Water Supply Financial Plan and Rate Study Update. The Chair recognizes Mr. Joe Cooper.
Thank you, Chair Ndaya, members of the board. I wanted to take this opportunity to give you an update on our financial plan and rate study. Since our last meeting, when we adopted Resolution 889 to 2018, at the August board meeting, we have posted our schedule of rates and charges for furnishing water and water services for fiscal years 2019 through 2023. We've also conducted several other public outreach activities. We started outreach with the Department of Environmental Services regarding our revised rates and also a proposed bill redesign. And since our bills are combined, we wanted to collaborate with our sister agency in doing that. And we've also discussed our capital projects and our revised rates with the American Council of Engineering Companies of Hawaii and the Engineering Council, which is part of the Hawaii Lodging and Tourism Association, just to keep them informed and abreast of what's happening with our rates and charges in capital projects. And finally, in accordance with Section 201M3, we appeared before the Small Business Regulatory Review Board in September 19th to inform them that we had adopted the water rates, which we had earlier presented to them in August. That concludes my report.
All right, members, any question? All right, Mr. Cooper, that's the shortest presentation I've ever heard.
Yeah,
No slides.
no
Thank you.
slides, but we'll be back. Thank you.
Thank you. All right, next item, item number 4, status update of groundwater levels at all index stations. Chair recognizes Mr. Barry Usadala.
Mr. Chair and members, due to the rains, we have no aquifer index wells in low groundwater status. For August, our pumpage was at 147 MGD, which is right at our five-year monthly average. Of note, in August we've had 267% of normal rainfall. The 5-month moving average is 144%. So aquifer levels are static or increasing because of the decreased pumpage and due to all the storm events. All in all, the resources are in good shape. That's my report.
All right, thank you. Thank you for the report. Any questions, members? All right, thank you. Next item, item number 5, the water main repair report for August 2018. Chair recognizes Mr. Mike Fouquet.
Good afternoon, Chair Andaya and members of the board. During the month of August, we had 35 main breaks. I just want to, during August 22nd and 23rd, which was just about the time we anticipated Hurricane Lane to hit us, for some reason during those 2 days, we had a total of 8 breaks. And during that period, our biggest concern was our crews, because we didn't want them out there when the hurricane was hitting. But fortunately, we kind of avoided that. We got our mains fixed and we got out of there as quickly as we could. But we had some concerns at that time. Really concerned. The leak detection crew surveyed 50 miles, and we repaired 3 clamps that was leaking. Any questions?
Members? All right, thank you for the report. All right, I think that brings us to the end of our agenda. May I entertain a motion to adjourn? Okay, moved and seconded. All those in favor say aye. All those opposed say nay. All right, we stand adjourned.